And we are live and back with the good thing. I'm your host today, Jens, and you can already see we don't have Stefan today because last minute he figured out that he's actually on an airplane. I think he's currently about to board because he's coming over to Germany. We meet next week, and so yeah, he's currently traveling. But we found a very interesting co-host for me today. Welcome, Cameron. Hi.
Jens, thanks for having me.
Cool. Yeah, Cameron just recently joined 𝘗𝘺𝘰𝘯. He's a senior software engineer. He joined us with a focus on AI. And we have a couple of topics today. We want to talk a little bit about what happened with the TypeScript rewrite, which seemed to be not happening in Rust. And probably the biggest question they have to ask themselves is, why did they? Had they written it in Rust, they would have invited a bunch of questions, but no. Okay, so that's one topic we talk about. I'm curious about your opinion. We haven't spoken about that yet. And then let me see. I have this list. So other topics. We want to talk about vibe coding or in general, like coding with agents. Very interesting topic. We want to talk about MCP. I'm very interested in the topic. I think Cameron knows a little bit more about it. And first of all, we would like to get to know a little bit about you, how you joined 𝘗𝘺𝘰𝘯, what you did prior to 𝘗𝘺𝘰𝘯. So yeah, maybe give us a little bit of an intro.
Yeah, for sure. So I've been a software engineer for the last going on 10 years, working specifically with startups to help build artificial intelligence powered tooling. I have also worked with different organizations to empower them to do cool things with their data. Right before joining 𝘗𝘺𝘰𝘯, I was the chief information security officer actually at a customer of 𝘗𝘺𝘰𝘯. And I really enjoyed working with the team. And when that ended, I decided that it would be awesome to come work with the 𝘗𝘺𝘰𝘯 team. So here I am.
Great. And at the company where you worked before, you were using GraphQL Federation?
We were, yes. We had 13 different microservices that were all federated together through Cosmo. And our entire front end was leveraged that API. We didn't have any kind of other APIs that we used. So everything was done through GraphQL Federation.
Okay. And like in general, what's your take? What's your opinion on GraphQL Federation from a user/consumer point of view?
Yeah, I think it makes things really simple for both the front end engineers and also for back end engineers. I think it's something that empowers the engineer to focus on the product and to focus on building cool tools as opposed to having to worry about how to stitch together data, how to I need to get one field that, say, like the orders or billing service has onto the user that comes from the account service, so that the front end doesn't have to make 100 API calls. And I think that it just really simplifies that process, and there's no, you don't have to think about it. You can just deploy and it works.
Yeah. If you don't have federation, what have you seen in companies? What are the alternative approaches when you don't use federated GraphQL?
Yeah, so I've seen a couple. One of the ones that I've seen is that the front end just has to make multiple API calls. It has to call the account service, then it has to call the back or the billing service. It's not stitched together, which is inefficient on the front end.
If I may interrupt, because I want to categorize these. So in this scenario, you could say you're federating in the client, right?
Yep.
Okay, so that is one thing we have seen. What are other approaches?
Another one, if we kind of go on that same category path, is federating on the back end, where the account service might make a call to the other microservice to get the data, as opposed to the client doing it. We do it on that side, which is, I mean, personally, I think it's a little better than doing it on the client, but it's still something that engineers have to actively think about and implement. And you have to think about microservice authentication, and you have to think about all of the different things that go into microservice to microservice communication.
If you do it in the backend, it means, so the latency for these multiple calls, it will be better. So performance is better. But in terms of complexity, we're now creating an endpoint that has more capabilities because it federates, right?
Right.
And
Exactly.
like in technical terms, we kind of call this like a backend for front end. So for this specific use case, we create a BFF, or even worse, if we don't create a BFF, something that I have also seen a lot in the past is people add stuff to REST APIs. So, hey, can we get some more data? Just add it to the REST API and then expand it. And then if you have a BFF approach, for example, we work with SoundCloud together. They used BFFs heavily in the past. And what you eventually end up with is, so you have one front end and one back end, then you add more front end capabilities or more front ends in general. So you expand your backends, or you go the BFF approach. And if you start the BFF approach, then you start adding BFFs. And eventually you end up with, like, you have N clients, M BFFs, and I don't know, O number of backends. And you create like a very interesting matrix configuration. And one feedback I got from many customers is, in this kind of configuration, it is often very hard for someone on the backend side to understand who's on the client side, because they don't have all these client teams in their team, because it's other people, maybe even in other parts of the organization. So what then happens is you can very easily break clients. You can very easily break dependencies between services because you don't know who's using you. And also, what you need in the front end side to make it somehow scalable and work is you add more and more contract tests that somehow try to articulate that there is a contract between clients in the backend, clients in the front end, and our microservices. And this whole level of complexity, Federation kind of deals with it. Like, it has constraints, but in Federation, you have your supergraph schema, you have your subgraph schemas, and you have clients using that. And then you have a schema registry like Cosmo. And Cosmo knows the schema of the supergraph, it knows the schema of the subgraphs, it knows like your linting rules and other things. And it knows all clients by name, version, and what fields they use in what query and when. For example, it knows exactly, oh, we have these 20 clients, and these are the, I don't know, 2,000 queries they made over the last 30 days. So now if you change a subgraph, first of all, you know who's using you. You can look at the analytics. You know that, so you can talk to the people. And second, if you are on the client team, it's actually very easy to figure out if you, let's say you load an entity and it needs an additional field. You can actually look at the schema of the supergraph. You can figure out where is the stuff in the supergraph coming from, like which subgraph. So you can figure out who are the people behind that, because the schema registry, it's kind of like a map for you to map like things in your domain to people. And so you can figure out who are the people, you can talk to them. And then in terms of breaking changes, we have one customer who reported, once they moved the project onto Federation, they saved more than 30% of the time in QA for contract testing, because they just wouldn't have to write the contracts anymore because we have this command wgc check. So you run a check when you want to change a subgraph, and then it verifies that you're not breaking clients. So yeah, overall, you can have, lots of people have opinions on GraphQL. It's good, it's bad, it's replacing REST, it's not replacing REST. But at the end of the day, I would say our opinion at Wundergraph is we're actually not like GraphQL is the best thing in the world. We're more like federation allows us to have many clients and many backends, and without this middle layer in between, and without the matrix, and we know what is using what and where is something coming from, and we can prevent breaking. So yeah, like for us, federation solves a huge problem of scaling clients and backends. And if you want to scale a company, it means you're adding products, it means you're adding business logic, so you add backends. So yeah, this needs to live somewhere. So
Exactly.
Yeah, anything you want to add?
No, I think you hit the nail right on the head. It's just a really great tool, in my opinion, to empower scale and ease of use and to empower stability.
Yeah. Which leads to the next topic. So, like I said, we like federation, but one problem of federation is it relies on GraphQL, and not everybody knows GraphQL. Like the majority of the market has not yet adopted federation, has not yet adopted GraphQL. So one topic we're working on is we want to make federation, like again, like when we think about what we're doing, we're thinking less about GraphQL, we're thinking more about federation, like the problem, like we solved the problem I just described. Federation or GraphQL is a detail. So one of the challenges we find is that as you bring federation into a company, more and more people are interested in using it, in leveraging the graph, and obviously your graph, it becomes a more powerful asset for the company if it's more capable. So there's like a flywheel effect. You have more users, you have more use cases it can do, and then it attracts more people. So how can we get more people to leverage the graph, maybe even without understanding GraphQL? And this is something where you came, you joined us, and we started exploring new ways of dealing with GraphQL. So maybe we can expand a bit on that.
Yeah, for sure. So one of the things that I've been exploring since I joined the team is how we can leverage artificial intelligence on top of a supergraph or even some subgraphs to empower people like business users, or empower front-end engineers who've never encountered GraphQL, or really anyone to be able to query the graph, to be able to just ask the graph, hey, how can I find out how many users are in this organization? Hey, can I get this user's name? And it can spit out the query and help them run that query against the graph. And it's something that personally I feel like will really empower and allow even people who are super familiar with GraphQL that haven't worked with that specific schema before and might not fully know the schema. It will be a faster way for them to find new queries, to figure out the data they need, and to actually activate and use that data.
Yeah, this is a good point, because so one use case is we give people access to the API that are not really developers, business people. That is one use case, and they might not even know how to write a query. For them, it's truly helpful because they can have a chat interface to talk to the API. That is helpful. But also for developers, if you look, for example, at let's say you have a schema like GitHub. How big is the schema? Do you know that on top of your head?
It is like 336,000 tokens.
Okay, what was that in lines of code?
in lines of code, I want to say it's like fifth. I'm not 100% sure, actually. I think it's like 1,500. It's in the thousands.
Okay, in the thousands. And like, obviously it's impossible to quick read through that. And so what we could now do is we could go to the GitHub documentation and search, and probably they have a good search function. Like every API should have a good documentation. But at the end of the day, the question is, will every company build GitHub level documentation for every API they have? We think that's kind of hard to accomplish. And then there's this other question: if you have graphical schemas with, I don't know how many thousands of lines of code, how can you actually navigate that? But because even if you're a dev, even if you know how to write graphical queries, how do you efficiently navigate a big graphical schema and understand, okay, how can it help me? How can it solve my problem? And you could now say, it's easy, simple problem. I just take the schema, I dump it in my file system, and I just ask ChatGPT to look through that, and then we're done, right? Is it so easy to do that? Or what are the challenges working with, like, if we build an application that looks at the graphical schema and then we have a use case and it should give us a query, well, where's the challenge?
Yeah, there are several challenges to think of. So the first large challenge that I see to do it quickly is, especially when you get to the GitHub size schemas, or you get to, any large GraphQL schema, you don't want to be putting that into the model every single time you want to query it. You want to figure out how to slice it and only give the model access to the data it needs to generate that query.
Why?
So you want to do that because of speed, cost. You can also hit the limit of the maximum number of tokens that the model can actually process in context. And once that happens, it will lose parts of that memory. And for all you know, it might be that very, very top line that it actually needs. So you need to figure out what it needs in order to allow it to accurately generate the query.
So you said speed, you said cost. Is cost really, like, are we talking about cost here, or is it like an artificial problem that you think it exists?
It's in the current state of the market, it's not as large of a problem as I think it will be in the future. As models get more and more stable and more accurate and more able to do things, I think we'll see the cost rise. However, right now, if you're constantly querying Git all day, you're still not looking at, if you're constantly uploading 400,000 tokens, you're not looking at a super nominal cost. Like, it's still something that will add up over, a month or 2 months. It's something, it's not going to be tens of thousands of dollars, but it's still, if you have 20 engineers querying it, it still could be thousands of dollars. And that is something to kind of think about when you're looking at an organization and how an organization can implement a tool like this at scale, is that scaling factor of cost.
Yeah. And the other problem you mentioned, performance. So let's say a schema has hundreds of thousands of tokens. Do we always have to stick that into the context, or like, is that necessary? And also, does it lead to good results, or what is a better approach?
Yeah. So when you just stick the entire schema in, it leads to a very slow time to actually generate the query and generate the response. But it also is not necessarily the most accurate because you're overloading the model with data. So you're giving it way too much information for it to try to parse through all of it and know exactly what's happening. Because, there could be like a user could be returned from both a search result and from a viewer field or from a me field on the schema, on the query type. So, having it identify the difference in those things is a little, it's not the greatest. You get some weird queries out of that. And so by slicing up the schema into basically what I call like the root types, you're able to do some very interesting things in order to actually calculate and figure out the vector distance between the query and the different slices of the schema, allowing us to only inject pieces and parts of the schema as opposed to the entire schema as a whole, which produces better performance, lower context usage, and it also allows for better accuracy.
When you say, I think you mentioned root types or something, right?
Mm-hmm.
What is a root type?
A root type is basically what anything that is returned by an operation. So, like if you have create user and it returns a user, and then you have get user and it returns a user. One sliced schema would have a query with get user, and the mutation type would have the operation of create user. And so it's just that very base root type that is defined as a return type on the mutation or on the query types or the subscription type.
So you mean like the fields on the root operation types, like query, mutation, subscription?
Yeah, exactly.
Okay, and so you take a root field, or you take all of the root fields, and what are you doing with each of them?
Basically, I'm grouping them by their return type. So I create like subgraphs of just only one return type. So only of the user type or only of the search result type. And that allows me to significantly reduce the size of the schemas, and also reduce the context, like not the context size, but reduce the amount of information that I'm passing in, because I'm only passing in one, there's only one real return type that's possible. And then I enable the model to use tools to actually find other types as well. So like, for example, you might in the GitHub schema, you might ask for the number of stars on the WonderGraph or the WonderGraph Cosmo repository, and you might ask for the current user's username. And so what it would do is it would return in the initial run, it would actually it would give the repository, and it potentially would return for a secondary subgraph or for the secondary sliced graph of the user slice. However, even if it doesn't, the model actually has access through tools to enable it to requery and re-look up for different root types so that it can still access the data from other root types and answer complex queries.
Okay, got it. And one other part you mentioned earlier is, I think you mentioned the term vector.
Mm-hmm.
How do vectors play into this whole exercise?
Yeah, for sure. So we are using a vector database to do this. However, the way that really any natural language processing works is that, I mean, really any artificial intelligence is that you calculate you turn everything into a vector. And specifically with natural language processing, the placement of the vector is determinant of the similarity of words. So like a user and a human aren't the same thing, but they would be pretty close to each other in terms of where they are in the vector graph. So you would be able to search for a user, and the distance would be filtered down by how far apart that vector between a user and a human is. And that's based off of the embeddings model that you use to actually generate those vectors.
What is an embeddings model?
The embeddings model is basically, it's the tokenization model. So it's actually how the vectors are calculated, and it's trained on all of the data that goes into training something like Gemini or Claude or ChatGPT. So it holds where those items live. So it like going back to the human and user, the embeddings model would actually be the one that would calculate and learn that human and user are near each other and close to each other.
So that means, so frankly speaking, you read a lot of books, and from these books you kind of learn that human and user, somehow they are correlated, and so they are nearer, or whatever you would say. And so this is then what in the embeddings model, if you put user, like I assume like an embeddings model, let's say it's a function you put in whatever and it gives you a vector, kind of, right?
Yep,
Okay.
it gives you the token, which is
okay,
vector.
And so the vector of human and person would be closer or more similar than a vector between human and car. Okay, and now we have our query, we have our prompt, like, hey, I want to get the stars of the 𝘑𝘺𝘵𝘗𝘚 repository. So you take this text and you also make it a vector, and then you search for your slices in the graph that are most similar to that.
Yep, exactly.
Okay, so on a high level, you're kind of saying, I have a question. Take a look at all the parts of the schema that you have indexed that are most similar, and then load those into the context, and I give you then the prompt again, maybe in some other format, and then you tell me how to write the query to do that.
Exactly.
Okay. And then if we do that, we know there's this topic of hallucinations. So how do I know that the query that it generates, can I somehow force it to create a graphical query, or will it just create text? Or how do I get to the point where it actually makes me a graphical query and that query is actually valid?
Yeah, so I handle that in two different ways. So the first way is actually by in the prompting, which is, it works most of the time. I actually require
60% of the time.
Yeah, it's why it's why it's two steps, not just one.
Okay.
But I provide it with a tool, the validate query tool, that allows it to actually verify and validate queries against the full graph spec. So it'll actually run a validation on the full GitHub query, or not query, the full GitHub schema, and it'll return back to the model the validity of it, or if there are errors, any errors that happen. So that kind of acts as like a feedback loop almost, to give the model context and information about that graph and where it's going wrong. And then the second thing that happens is actually verifying the query and parsing out the response after the model says, hey, I'm finished, I think this is a valid query. I actually validate and verify the query post response. So I will parse through the returned values, and I will find the query, and I will revalidate it and triple check it against that schema again to ensure that it is accurate.
Yeah. One pattern I have seen with using cursor is, and I think this is really smart. We will also talk about what are good languages for vibe coding. But one thing I saw is when you have like cursor write code for you, it immediately uses a linter, which I think is pretty smart, because if you have an AI write something and then you run a linter over it, linters give you very good information about the thing that you just tried. It's actually wrong, it's broken. So if you do that, you can immediately feed back the linter result to have it properly format the query or whatnot. Or maybe it's even not parsable because it's broken, then you can fix that. So are you using like a similar technique?
Yep, that's pretty much exactly what the verification is doing. Right now, I'm not doing any kind of actual linting on the query. I'm more just ensuring that the query it returns can be parsed into AST, and then I'm validating that AST is valid against the current schema. However, as with anything in this world, there's still a lot of experimentation to be done around, does it perform better when we add in a linter and feed that back? How does it perform? And what tweaks to this can we make to make it more accurate, more performant, and just overall better?
Yeah. Okay. Which we can actually use as a transition to the topic of vibe coding. For those who don't know, like what do you consider vibe coding, Cameron?
Whenever you're working with like something like Cursor or any of those tools, and you're just really able to move quickly, and it kind of saves time, and it's being actually helpful, if that makes sense.
Yeah. So the way I would describe vibe coding, or I kind of say like coding with an agent, or coding in agent mode. Like, for a very long time I was using GitHub Copilot. So that's kind of the approach where you tap, and it kind of gives you a better auto completion. And then after a while with Copilot, we had this new feature where we can mark some code, and then we can write a comment to change this code. And now agent mode, it's kind of completely different. You tell it like, hey, here's a bunch of files. Here's what I want to do, and it kind of changes all the files for you, and it makes all the edits. And it's an interesting approach. What is your experience so far? Like, where does it work well? Where does it not? Like, what is it good at? What are the problems? What have you observed?
Yeah, so I heavily use Cursor. I actually was not a big GitHub Copilot user, believe it or not. I really liked Cursor. However, I found that it works really well with front end work. So with building out like things in Next or React or Vue or any of those different front end frameworks, and even on the back end, it works okay. One of the big challenges, though, that I've found is actually when doing prompt engineering and working with AI prompts, is that it'll try to autocomplete and try to autofill things. And AI prompting AI is not at a point where it's super great yet. So I've just found that if you're not careful with what files you allow it access to, it will mess up your prompts. But doing all of the things that are time consuming is just super simple, like writing SQL migrations, writing comments, helping to write tests, helping to build out data models, like those types of things. It is super powerful, and it's a very helpful tool for an engineer to have in their back pocket to be able to move extremely quickly.
Yeah. What I found where it works really well is if you give it a pattern and you want to replicate this pattern for other things. So let's say you create like a design of a new solution, and you make the design for queries, and then you tell it, okay, can you do the same thing for mutations? Because it's kind of almost the same, but it would be nice to have also a spec for mutations. But you are lazy, and it's very good at that. One use case where I found it to be dangerous is, so let's say you have an AST in one language, and you want to make some transformation and create an AST in another language. So what I have found Cursor doing, and this, like, you need to be extremely careful with this kind of stuff. So you add a simple use case. So I'm the way I try to approach it is, I try to start with something super simple so that I bootstrap like one function that does one thing, and then I add another test case. So I go like very test driven. So I start by writing one test and an empty function, and then I tell it, hey, implement this. Okay. And then I write a second function where I add one more feature. So I make this test a little bit more complex. And for example, one pattern I already observed is you need to be thinking about, do I want to stick all tests in one file or one file per test? Because like these files, they can quickly go super large. And then the model might get confused by so much context. So these are things you need to consider. But what I have found is, so you start with a simple use case, it implements it. Then you add a more complex one, it figures it out. And then you add like a really complex one. And what I have observed there is, so again, this use case is AST transformation. So you have one AST, you turn it into another. And so I was using 3.7 Sonnet agent model. And what it kept trying to do is, instead of writing a function that looks at my AST and tries to dynamically, or tries to write code that dynamically derives something from the AST, it kept hard coding AST literals into the implementation for a specific use case. And I had like over and over, I had to force it and tell it like, hey, don't do that. Do it dynamically. Write code that looks at the AST and that derives this kind of function. And that was really, really, really tough, because I don't know, it just wants to go like the simple route. But do you have similar experiences?
Oh yeah, very very much so. I've there was something the other day that I was working on, where I was working on doing an implementation of within our artificial intelligence work, that of kind of an extraction layer, and it just kept wanting to even override me sometimes, which was a little frustrating, because it would want to override me to actually put in like hard coded defined literals, as opposed to doing something dynamically and actually extracting it to where it is an extraction layer and not just a copy and paste of JSON information into Go. So that's why, like, for me, I really have enjoyed using it to do kind of the opposite of what Jens has been using it for, and using it to write tests to validate the code that I've written, or to help write comments out, to kind of almost using it like my second set of eyes, as opposed to the like you being the human being the second set of eyes, almost doing it kind of reverse.
If you have the model writing the tests, which is I think it's a good idea, can you somehow ensure that it's not looking at your implementation?
It probably will look at the implementation, to be honest. Yeah, probably. But I mean, you can, with Cursor at least, I know you can define what files it uses in context. But my guess is that odds are there's, something that enables it to look back at the implementation. However, I think that is somewhere that AI is helpful in, is that humans might look at that implementation and have a bias towards ensuring that it works and ensuring the test pass. Whereas AI is not necessarily going to have that bias. Whereas, I've found that it's more likely to come up with test cases that are failing, even in a state that I would expect. Like, I found it comes up with some crazy edge cases sometimes, is what I'm getting at there.
Yeah. I was thinking it's a bit like the pink elephant kind of scenario. If you tell it, don't look at implementation.go, what will it do? Will it ignore that? Will it think, oh, he mentioned implementation.go?
My guess is it's gonna go after the second one, and I kind of want to try that now and see what happens.
Yeah, it will probably look at the file and be like, okay, I should not look at the file, so I need to read it to know what I should not look at, right? So yeah,
Yeah.
very, very interesting. But like overall, like I can say it's a super useful tool. For me,
I agree.
one scenario where I found please write me a story that has absolutely no cats in it. Okay, yeah. Thank you, David. Here, message from David. That makes a lot of sense. Yeah. So one scenario where I found agent mode super useful is writing RFCs, because I'm super lazy. Like, and so if you write an RFC, so two scenarios where I found it useful to use cursor. The first one is you write an RFC, and after a while you come to the conclusion that you made a mistake. Like, that's very natural. You want to refine the RFC, so you want to make significant changes to like a root concept in your RFC. If you do this by hand, it means you have to go through this whole document, and wherever you use this root concept, you now have to make changes, and it's gonna be tough. It's gonna be like, you can very easily forget something. With cursor, it's so good. You just tell the AI like, hey, here's this root concept. I don't like it. I changed my mind. And can we refactor that? And then it will go through the whole document, make the changes. It will tell you like which part of the code it changed. So that's pretty useful. And the second use case, I really like this. So you create your RFC, you publish it to GitHub like a markdown. You create a pull request so people can comment. You let them comment, and then you take the URL with the comments, and you tell the AI, hey, here's some comments, some feedback. Apply the feedback to the RFC. So you can have AI read the comments and apply them, and then you can review, okay, how would it look like? Like, do I like this? I mean, you don't have to accept it right away. You can just iterate on it. And yeah, I find it very useful. Also, some other things I did is in Cursor, you can index websites and documents. So for example, I indexed the documentation of WonderGraph. I indexed the GraphQL specification and some other websites. And then let's say you want to work with GraphQL or write an RFC about GraphQL or something. You can look at these documents. For example, there's a working group, the GraphQL composite schema working group. It's working on creating like a federation specification for GraphQL federation. And let's say you create an RFC that is in the federation space. You can just ask Cursor, hey, I have this RFC here. Take a look at the federation specification from the composite schema group. Are there similar concepts, and how are they dealing with this situation? Do they have an opinion on that? And then you can learn from that. So I find that very, very useful. Any other topics? Any other like approaches or patterns you're using?
Yeah, I think I really relate with the RFC type approach. I think that it's I've used it largely to write documentation and keep track of things that to help me like just share what my brain is thinking as I'm going through and writing code and writing things that make sense to me at the time. And being able to have a tool that can document it well in either in comments or in just like a markdown file somewhere is very helpful to allow me to bring in other engineers to give people the information they need. And I think that that's something that I don't necessarily enjoy doing, so I think it's something that is very helpful for me.
Yeah. And to be honest, like, I think even, for example, reporters or like non-dev people should consider using Cursor, because let's say you're a reporter, you're researching for a topic. Create a project, open Cursor, and let's say you have a bunch of websites and Wikipedia articles and sources that talk about this topic. Like for each source, create like one agent tab, tell it to read the website, figure out with a prompt the relevant information, something, and then I don't know, you can use it as a research tool. I think Cursor is not just like a coding tool. You can do research, you can write, I don't know, content. I like to write it with to use it with writing blog posts. But I have like one note I have to make, because for me blogging is an art, and I think quite often you can see when someone wrote an article with AI. And for me, it's a big difference if I ask an agent to write an article, or if I use, for example, auto-completion to complete my sentences. And I have to say, I don't know, but I don't like using the agent mode for writing blog posts, because I think it's not authentic. It's too much. It's too much following like a structure and a pattern, and it's not, for me, it's not human. Like I want to have the human touch in articles.
Yeah.
I'm not sure how you see that.
Yeah, no, I totally agree. I think it's actually very important. And a lot of the big search engines have actually found ways to identify fully AI generated content, and have started flagging them and tagging them, so that so then your blog doesn't really help you as much as a human written blog post might. So I think I think as we kind of get further and further into AI and into how AI can work with us, we have to be very careful and cautious of validating and backing up what AI is writing, and adding that human touch to what it's to what it's outputting. I mean, even in code, there's a certain level of need still for an engineer to actually sit there and look behind the model and make sure that, because there are things that an engineer can see dynamically that the model just can't. Because at the end of the day, a model is just probability. Like, it's just the probability of something happening. And yes, that's kind of how our brains work at this too. But our brains can take in so many more parameters than a model can look at. And that enables us to think, 100 miles wide compared to 20 miles wide.
I think another part is also taste. So
Mhm.
I'm not sure if a model has taste, but
Mm.
I definitely have taste, and like you can agree and disagree, and that's the good thing about taste. But if you, for example, see over, like you can see, like I wrote, I don't know, hundreds of blog posts over the years, and you see content and videos of me where I appear, and you can see I have a certain style, and I have a certain way to communicate, and I have opinions. Like over time they change a bit, but overall, like you can see, like I have like a signature, right?
Mhm.
And I think it can be really hard to if you just look at content from vendors, or you go through tech blogs, and they all have like the same style, the same, from the model derived style. Okay, you can tell the model to have a certain style, but is that personality? And I think also when we're now building software with models, it's increasingly important that we have our style, that you can actually see, oh, this is 𝘑𝘺𝘵. You know what I mean?
Yeah. No, I totally agree. I think it's, there's nothing interesting about everything being cookie cutter. It's just like we don't talk in monotone. We talk with, deflections in our voice. We write with that too. We just, that's just human, and a model's a computer still.
Yeah. For example, I'm pretty sure you can read that I'm not a native speaker. So you can somehow see that. And that is one part of my identity. And I think it's actually good because you can, okay, yeah, it's a human, because AI wouldn't write this way. AI would like flatten this, or like, and
Right.
and maybe even in my language, how I write, you see certain patterns that are like, yeah, that is not how you normally write in English, but he's doing it all the time. So this is his thing. Okay, he makes this mistake all the time, and yeah, I think that makes the authenticity. One other
Agreed.
topic slightly correlated to this. We talked about cursor tools like that. Let's talk about MCP. So everybody's talking about MCP. We were talking about, okay, I can bring files into the context. I can bring websites into the context by writing like add web into the chat and other things. I can index websites and documentation, and I can also use this MCP thing. What is that?
Yeah, so MCP stands for the Model Context Protocol. It was a protocol that was designed by Anthropic. Right now, it's being implemented in their Claude models, so with Claude Desktop or the Claude API. The super high level basic of what it is that you have a client, which is the desktop or is the SDK, and then you have a server that the model runs. And the model actually communicates via JSON RPC in order to ask questions. So it's very, very similar to how something like Gemini or something like OpenAI or Mixtral actually allows for you to provide it with tools. The big difference is just that it's a defined protocol. It's a defined method to how to do it remotely without it needing to be inside, like with Gemini, for example, like it's actually in the stream of the model execution. So you have to iterate through the response candidates to find the function calls, whereas MCP, the model will actually take that onus off of the user, and it will actually call the function, then the server will return it, as opposed to you needing to execute it, then reprompt the model again, and then run through that whole cycle again. So it's kind of just a way to allow that communication efficiently and to kind of take the extrapolated out some and to set a defined protocol.
Yeah. So for those who don't know, in OpenAPI, you can define tools. And essentially, the kind of the way, like I find it really interesting how tools is implemented. But you make a request, and as part of the request, you also send like which is super expensive, by the way. You send that all the time, like what tools you have. But so you make a request with a prompt, and you also say like, "Hello AI, like imagine I had functions. Like I don't really have functions, but imagine I had." And they can do certain things, which I describe here in text. So do whatever you want. And if you think one of these functions would be somehow useful to what you're doing, then tell me to call the function. So they send you like a string where they say, okay, yes, call the function with the following input. And you can define the input with a JSON schema. And so you call the function. And then you tell them like, okay, this is the result of the function call, which is like, I understand why the model has to work this way, because you can't just you can't just have the model go outside in the world and call your service, because it's in the cloud, so it doesn't have access to your computer. But now with this MCP thing, what you're saying is I don't have to define tools over and over and over again and send them back and forth, but instead I can say kind of like, hey, here's an API, I follow a contract. And you can tell if you do this in the MCP spec, you can essentially like, yeah, you can prepare those tools, package them maybe, and then someone else can just use the tool. So someone else can say, okay, I have Cursor and I want to use one example I saw there. Someone built a tool that uses the Docker daemon, so it can talk to the Docker daemon and start containers. And so now if you enable this thing, then your cursor can now use Docker over JSON RPC, kind of.
Yep, exactly. So allows just a really easy way to package up those tools that we have already used, and it provides a way to package them and extrapolate them out so that you're not having to write extensions for Cursor in order to get it access to Docker. You can just say, hey, add this to that model. Cool. Now I can access Docker.
Yeah. Well, what I find kind of interesting is, I would consider myself an observer of the hypermedia world. There's this group of do you know what hypermedia is?
Somewhat.
Okay, so I can only answer this in the wrong way, because depending on who you ask, they will always say you're wrong. But on a very high level, hypermedia is kind of like the web works. So you go to a website, it returns hypertext, and in the hypertext you have URLs, and you can follow them, and it can somehow, for example, return using JSON LD or whatever schema. It can tell you there are certain actions, and if you send a post request to this URL, you can add something to the shopping cart. So that's kind of like hypermedia APIs. And what I find so interesting is now we have these super smart models and everything, and they are advancing. And still we go back to RPC and hard coding tools, because AI is not able to navigate the internet, or is it really necessary that we now map out the world in MCP, or where do you think this is going?
Yeah, I think it's going to take steps. I think MCP is a step towards making the tools easier for the model to use. I think we'll continuously see AI evolve into where it eventually can process the hypermedia. It can process RSS feeds. It can process even GraphQL schemas. Getting right to that, like being able to take that in and actually execute on it based off of what it can scrape and what it can find. But I think today it's still we're still limited by the fact that even beyond it's a cloud thing. It's still just, at the end of the day, it's still just attention heads and a feed forward neural network, or for mixtural, for a lot of the mixture of experts models, you'll have a router and then you'll have multiple different multiple different models behind that router. But at the end of the day, it's still just a model. It's still just processing numbers and vectors and weights. It's not, the human brain can conduct the rest of our body. It can tell our arms and our legs and our feet to do things. Today, these models don't have that unless we provide them things like tools through MCP, or tools through the Vertex AI SDK, or through OpenAI's SDKs. I think that's one of the big things that we have to kind of figure out, is how do we give them access? What do we want to do with that access? And should it be done on the model level, or should it be kept at the user level? So I think that there's still a lot to figure out there.
Yeah. Yeah, interesting. I mean, one way you could actually go with MCP is you could have, let's say you have like an MCP registry where the model can search for MCPs and then figure out which one to use. Then you have a new problem: authentication, authorization. How do you do that on the behalf of the user? And the other problem is, if you let the model run free and select MCPs on its own, you kind of want to regulate that or verify that. Then we kind of end up with a Docker situation where we need like a public registry where people can somehow validate that an MCP is actually official. So now you could say, okay, you can use the MCP hub, but only the official connections or whatever. Because I think in general it's interesting if every company opens up like an MCP channel, and you want to build integrations and work something out across multiple, like even think about you're like a bookkeeper, and you can have an MCP interface with all the banks you have and with your bookkeeping software and everything, and you can then ask a question like, hey, where's the money? Is it here? Is it there? Give me the latest transactions. Can be very powerful. And I think we will see new kind of tools pop up that are not geared towards developers, but geared towards business users. And I guess the foundation for that is something like MCP. So it's interesting. Last topic before we wrap it up. Microsoft has announced they are in the making of rewriting TypeScript in Go and not in Rust. Well, what are your thoughts on TypeScript in general, also in the context of AI? And what are your thoughts on this rewrite?
Yeah, I think it's very interesting. So I'm a big fan of TypeScript. I've used it frequently for front end and for some back end stuff. In the AI space, it has its place. It's being used more and more and supported by more and more groups. I think it's great for having just a basic serving engine. So just to be able to pass through requests back to like the OpenAI API, or for quickly scaffolding those types of things. But it's for model training and for actually doing any kind of like experimentation around models, I'm gonna choose other languages other than TypeScript. But that being said, I do think it's very interesting that they chose Go. That it was something that I did not necessarily see coming with Microsoft. You hear constantly about about compilers being written in Rust or C, honestly. And to me, Microsoft, their entire background is in C, C++, C#, .NET, all of those things. So I'm actually pretty shocked and honestly excited that they've decided to go the route of Go, because I feel like Go is a language. I always say that it really feels like the best of like C++, Java, Python, and TypeScript all in one. So I feel like it's a language that has a lot of power and has the ability to do more than we typically do with it. So I think it's exciting to see a large compiler for one of the mainstream languages be rewritten in something like Go.
Side note, GitHub actually uses Go internally to write some of their backend logic. But aside from that, what I find interesting, so I look at some of the discussions around this rewrite, and then obvious question like why not Rust? And some of the explanations I really I watched an interview, and what resonated a lot is when you have the compiler written in TypeScript, which is a garbage collected language, and you rewrite it in Go. And if you go like function by function, Go is a very similar to C. I would say it has structs. It has almost no magic, and you can probably, if you don't use so much functional programming, you can probably go quite straightforward from TypeScript to Go. Versus with Rust, if you build parsers and other things, and if you transform ASTs, one thing you have to deal with in Rust is this borrow checker, which helps you understand the lifetime of values. And then you get into the problem where, okay, let's take an AST and you want to rewrite it. So how long will that thing live, and etc., etc. So you have a whole bunch of problems that TypeScript and Go, they simply don't have, which means just by high level looking at the code, the Go code would be quite similar to TypeScript, versus Rust would be more complex, more complicated. Rust, it would probably give you better performance out of the box. With Go, you can also be pretty fast, but at the same time, there's this tool. I'm not sure if I remember, but there's tooling in Go already to compile TypeScript, like bundle it. So there's bundlers, some written in Go, and they are quite fast. So yeah, I mean, Go is quite performant, and I think in general, garbage collection can be a great feature because you don't have to think about memory management at all. And if you write, if you write a web server, you are somewhat concerned around like things like garbage collection, in the sense that you can have stop the world scenarios where the garbage collector really blocks your server from doing something. So if a new request comes into the server while the server is GCing, you can have latency spikes. At the same time, if you build a compiler, that's not really something you're worried about. You start the compiler, it does the thing, and then it ends, and you just free the memory. So I'm not sure, like, GC, is that a concern? Because you have so much memory, you probably just run through your work without doing GC at all, and then just throw away the memory. So that might even be a good scenario. So I can kind of understand it. I was super surprised when I saw it. I would have never thought that someone would write in Go. But at the same time, if you talk about the topic of what are good languages to write code in AI, and I think for web development, I would always, and I'm curious about your opinion, but I would always choose TypeScript, simply because you let it code something, and the first thing you can do is you run the TSC compiler, and whatever comes back, you throw it back to the AI to correct that. So I think that's one pattern. And then on the backend side, I saw a lot of people who like Kotlin. Like when it comes to backend, lots of people like Kotlin. I haven't used it so much. I think it's a bit magical to me. And I personally, like, I'm biased, obviously. I'm writing Go for many years, but I think Go is a great language to generate with AI, simply because Go has no hidden features. It has concurrency. That's okay, but overall, Go is just super simple to read. Like the code goes from top to bottom. It's boring code, and I don't know. It works. It's fast. It's good. What's your take? What language would you use for web, and what would you prefer on the back end?
Yeah. So for web, I agree with you. TypeScript is the way that I always go. I think that it enables you to have type safety and to be, you know, it's quick to write for me. So it's what I always go with. But on the back end, if we're specifically talking about AI stuff, I'm probably going to go with Python, and I know, or C++, actually, for depending on what exactly I'm doing. The reason that I say that and that I don't say Go, because I am, my background, I've worked a lot with Go and I really love Go as a language, is honestly, it comes down to tools and to what you have access to. With Go, there's a lot of things that are not supported still. Within the AI ecosystem. So you don't have access to do some of the things that you need to do to enable you to really keep track of the model and the model usage and how the model functions. So that's one of the hard parts with Go right now. And I think that we'll see that change as things mature and develop in the AI space. But that's really where I'm at right there. As for Kotlin, I've seen that a lot too. I'm not a huge fan, just out of personal preference, but I have seen it being used, and I've also seen Scala or Spring Boot as well. But I try to stay away from Java as much as possible, if I can. So
awesome. Yeah, great. I think it was a very interesting conversation. We went a couple of minutes over. Do you know what we always do at the end of the episode?
I don't.
Okay. What's the title of the show?
The good thing.
The good thing. Okay. You need to ask me, what is the good thing?
What's the good thing?
We're back in a week.
Woo! Yay!
Yeah.
Woo!
Okay, Cameron, thank you so much. This was a cool show. I will end the stream. Thanks everybody for joining, and yeah, see you in a week.
Awesome.
Ciao.
See you guys.